Algebra students, Mr. Lawrence here, and we're just going to talk really quickly about the graphing review. Just because we've been graphing so much lately, we got to remember what we know. By the way, I didn't mention functions in here. Maybe I'll throw some functions in at the end. I think that's a good idea. I'll do that. Okay, we've talked about slope-intercept form of a linear equation. Looks like y equals mx plus b, where b is the y-intercept, right? That's the y-intercept. And this is our slope, our rise and our run. Okay, a rise over a run. Now, remember y must be alone. The standard form of a linear equation, which looks like ax plus by equals c, and a must be positive. A must be greater than 0. Okay, linear inequalities, when we have, looks like an equation, except we'll have a less than, or a greater than, or maybe a less than or equal to, or maybe a greater than or equal to, right? And those involve shading and sometimes dashed or broken lines. Okay, systems of linear equations, when we have two lines intersecting at a point, usually intersect. Forget who said that, but they said it so well. They usually intersect. Maybe that was Laney. Yeah, I think that was Laney. They usually intersect. They don't always have to. Okay, and then systems of linear qualities, which we did on Friday, which I really didn't teach you because I figured you could figure out on your own. And we're going to do one or two of those just to make sure you're good with it. All right, so let's get on to it here. First of all, I have just a simple linear equation. Looks like it's in standard form, and a is positive. So I'm going to remember that my x-intercept, can you remember what it is? How to get it? C divided by a, 0. The y-intercept can be found by doing 0, c divided by b. And then the slope can be found by taking the negative of a over b. Now, to get any line from standard form of a linear equation, I only need two of these three things. In this problem, I'm just kind of cheating, and I know 4 doesn't go into 15 evenly, so I don't think I'm going to worry about the y-intercept, because it's not going to come out as pretty. 3 goes into 15 evenly. I think I'll find the x-intercept. I think it's going to be 5, 0. 1, 2, 3, 4, 5, 0. Yeah, 5, 0. The x-intercept. The slope is going to be negative a over b. Well, a is 3, so we're going to get negative 3 over negative 4, which simplifies to 3/4. Now, I can use either form of those slopes. They'll work. Let me go. Rise. 1, 2, 3. 1, 2, 3, 4. Wow, I ran 4. Am I tired? All right, let's rise. Negative 3. 1, 2, 3, and run. Negative 4. 1, 2, 3, 4. There we go. All right, so I can draw my line, everywhere a line. Taking up my graph, taking up my time. Don't forget to find the slope. Can you see my line? Sorry, that was bad. But anyway, all right, there we go. That's pretty simple. Okay, remember you should be able to check on the graphing calculator, but you have to go to slope-intercept form. So if I go 3x minus 4y equals 15, to get to slope-intercept form, I will subtract 3x from both sides, and then I will get negative 4y equals 15 minus 3x, and then I'll divide everything by negative 4, because I like to sing, but I don't do it very well, but that's okay because I know it. All right, let's see here. It looks like I'm going to get a negative 3 3/4 is my y-intercept. It's a little bit ugly. And a positive 3/4 x. Now, I'm looking at this, and yeah, my line might be off a little bit. It doesn't look like I'm hitting negative 3 3/4. And look, there's the problem. See, I'm not hitting that point well enough. I think to... Yeah, there we go. That looks a little bit better. And this point here looks like this. Oop, I moved a whole line. He's not at the intersection. Let's see if I can get it back. Oh dear. It's pretty close. See, it's not quite there. But it's hard to tell. So, let's go to the graphing calculator. Let's go to the graphing calculator. Oh, graphing calculator, where are you? Please open up. Please. Thank you, graphing calculator. I feel like Elmo because it's Elmo's world. La 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 la. Sorry. Let's see here. Where is my equation? I don't remember. 3/4 x and negative 3 3/4. So to do 3/4, I can go 3/4 or I could go 0.75 because it means the same thing, right? It's a little bit easier to type. X minus, now 3 3/4, I might as well go 3 3/4 like that. It'll be a little bit easier to type in because the graphing calculator doesn't do fractions that well. If I was going to do it as, I might go mixed number instead of an improper, or I might go improper fraction instead of a mixed number. That's what I'm trying to say. Sorry about that. Okay, so let me zoom 6. And there's my pretty blue line. And we're going to trace. And look at that. My y-intercept is 0 and negative 3/4. Now, my x-intercept was 5, I think. 1, 2, 3, 4, 5. Right? Was that it on my graph? Let's see here. Yep, 5, 0. If I go back and I type 5, sure enough, I get 0 out. I can check other points that way as well. Let's see here. It looks like 1, x is 1, y is 1, 2, 3, negative 3. So I can go 1, negative 3. Now, if you wanted to, you could have just checked the table. Right? Check the table. And there's 0, negative 3.5, or 3 3/4. 1 was at negative 3, 5 was at 0. If you check 2 of those points and they match, you know you did it right. All right. Thank you, graphing calculator. All right, so let's try this next one here. Ooh, it's some ugly colors. Ooh, I apologize for this poor color choice. But let's see, this one here, this blue one, is almost in slope-intercept form. So I think I'm going to divide by 2. Divide by 2, and that'll get me the inequality of y is less than 3 minus 3 over 2x. And so I'm going to graph my y-intercept to 3, 1, 2, 3. Slope of negative 3 over 2, 1, 2, 3, 1, 2. Okay, 1, 2, 3, 1, 2. And it's going to be a broken line. A broken line, a broken line. I need to make it a broken line. I better make this thing extend for a while because I'm not sure where the overlapping region is going to be. Yeah, it's close. It might be off a little bit. I might have to adjust it. Get an arrowhead on there. Yeah, I'm going to make it blue. No, that's pretty close. I think I'll leave that in place. I'm going to lock that in place so I don't accidentally move it. All right, now I got to do my test point, and I'm going to use the origin. If I put 0 in for x and 0 in for y, I get 0 is less than 3, which is true. What's true is true. So I need to shade down here blue. All this is going to be blue. All of it. Okay, and it'll go to the line, but it won't touch. The line is not a part of the solution set. That's what the broken line means. All right, I apologize if I'm getting quiet. I have a bit of a headache right now. Not that you needed to know that, but hey, just like filling in the time. All right, let me go do the ugly urine colored one. All right, let's see here. Hopefully you can see that yellow. I'll tell you what, I'll do the work in this maroon color. Oh, it's in standard form. That'll be easy. Let me find the y-intercept right away. The y-intercept is going to be 0, 4. I just did c divided by b. My slope, I believe, is going to be negative 6 over 2, which is negative 3 over 1. All right, so I'm ready to do that one. I can go plot those points. My y-intercept is 0, 4. 1, 2, 3, 4. And then I'm going to go down 3. 1, 2, 3, and over 1. And down 1, 2, 3, and over 1. And down 1, 2, 3, and over 1. And up 1, 2, 3, and over 1. And then I will get my line. 1, 2, 3, over 1. Bump, 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 bump. Da-dum, bump, 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 bump. Alright, there we go. I can't, oh, black and yellow is almost bad as blue and urine. I can't handle it. Alright, let's make that yellow. And, alright, there we go. Now I got to test my shading for the yellow one. So, oops, I want the highlighter. Highlighter. There you are. Okay, so if I put 0, 0 in, I get 0 is greater than 8. Well, 0 is not greater than 8, so I will not shade the origin side of the line. So I'm going to shade all this over here, all this over here. Whoa, look at that. Oh, isn't that the coolest thing ever? Yeah, that's like almost as cool as peanut butter. All right, very good. There we go. Now, for what it's worth, the actual shaded region is this whole piece going out. Okay, there you go. And it would all be green here. There won't be any blue left, but it's hard to be 100% precise. So you see the yellow and the blue make the green, and there you go. That's your solution set. Okay, makes it very obvious. Okay. By the way, I got to tell you, I am proud of the job most of you are doing lately. I'd love for you to pause this one, see if you can do it on your own. Here comes my solution. Let's see. X is greater than 2. That's going to be a vertical line, isn't it? So let me find my lines. Oh, line, where are you, line? X2 is going to be like that. And it's broken. And I'm going to shade. Greater than 2, I'm going to shade over here. It's hard to be precise. I apologize for my lack of precision. All right, let me see if I can clean that up a little bit. A little bit. Little bit. There we go. Okay. Oops. I went too far. Gosh darn it, I went too far. Okay, that's pretty good. All right, now I need that yellow one. Yellow. Well, that's just going to be a horizontal line. A horizontal line that goes through 8. It's going to be something like that. And the shading for that one is less than, so it's going to be below the line. So I'm going to shade here. It's going to take up the whole graph, right? There we go. Now, if I was only doing 2 inequalities, I'd be done because my green region would be that lower quadrant. But I have this red line, which is like x equals y. Well, that's going to have a y-intercept of 0, and the slope is going to be 1 over 1. And so it's going to look something like that. Looks like my graph paper is kind of inaccurate because it should go corner to corner, but when I do that, I miss. So yeah, I'm going to have to go with that. It must be handmade graph paper, computer made by me, and therefore it's not perfectly accurate. But anyway, let me see here. I need my highlighter, and I need red this time. And let's see. Can't use the origin. How about if I use the point 1, 3? 1, 3. 1 is less than 3. X is 1. 1, 1, 2, 3. And 1 is less than 3, so that point needs to be in the shaded region, so I'm going to shade everything above. Now it's not turning orange there, but you can see how this green region turned this ugly black. That is your solution, that black triangle piece. And it is a triangle, it's a triangular shape. And if you want, I'll erase all that so you can see it better. This triangle right here is the solution set. Okay, so there's a little bit of that. Now, a couple of quick function or no function problems. All right, I gave you -2, -1, 0, 1, and 2. And then I want this to go to 16, 1, 0, 1, and 16. Let's see, let's do this one here. Let's go with 16, 2, 0, 2, 16. And let's go with 8, 1, 0, 1, 2. And we'll make those 2 negatives. Oh, I don't want that at 2. I want that at 8. Excuse me. Okay. And then 2 quick graphs. Determine if they are functions or relations. Functions or relations. Okay. So the x-axis, y-axis, there's my origin. And then one more, total of 4 problems here. X and y. And then, let's see, we're going to go like that. Okay. Determine those if they are functions or not. So we'll call this number 1, number 2, number 3, and number 4. Okay, what I'd like you to do is write this down in your notes, whether you think they're functions or not. It's not a video quiz. Just write it down, and we're going to talk about it briefly on Tuesday. All right, Mr. Laurence signing off. Have a good night, everybody.